बोतल यहाँ रखो, समझा, बोतल देखेगा अच्छा लगेगा। अरे सही बता रहे हैं।
Okay, bhai. Just have to check it's working or not. एक- हाँ. Hi guys, this is Sasi, and today we are going to revise our whole syllabus of machine learning via this work is done by our Kaushal Kishore sir, and he will revise whole syllabus in one go, approximately 2 hours maybe, or less than 2 hours. So please enjoy the session and ask some questions if you have any questions. We will try to answer that question in chat. So now, uh, Kausal KK sir is coming here. Kausal, please take over the session.
So it's live.
Yeah.
Uh, Hello guys, but there is no one right here. But there is nobody right here.
Okay, okay, one second.
Okay.
What's the problem? One second. PPT second. One second, guys. We are going to share our PPT so that you can see. Kausal, introduce yourself so that.
Hello everyone. This is Kaushal Kishore from VIT Sindri, branch Civil Engineering, batch 2023. And today I'm going to just discuss a little bit on machine learning. As tomorrow is our exam, so we are kind of nervous and excited too at the same time.
What? Okay.
So,
Continue.
Mr. Sasi, let's start.
Yeah, wait. I'm to. It will take time, so please wait. I will share some PDF so you can see what he is teaching.
But we are going to cover more than video, right?
Okay. Just for your
Reference purpose.
reference work. It's taking time.
Network is little bit slow today.
Actually, I change the location every day. You see in different location, and today is
The green.
this is premium room with name
trees and
name
banana
trees with frogs come directly inside the room in the top floor as well.
Not every day, Sachi.
Yeah, but sometimes it's enough to reject yourself.
Yeah.
Yeah.
It's a lot to open.
6 pages only.
Yeah, that is what I thought in the class, so I thought just to say that.
Okay.
And I didn't prepare more about that. But you know,
So I'm going to share a screen. So Mhm. So it's all on you, person, sir. So
not me.
so if you have to scroll this, just go on this slide and just scroll. Okay, go and just scroll this way. Black. Okay. See.
So, Mr. Sasi, won't you come here?
Okay.
You also come.
No.
Okay. So, guys, let's start now. Actually, the PDF shared here is of the class notes.
Question answer दीजिए ना.
Yeah. How do you spell that? Huh? How do you spell that?
If you want to scroll that, you have to go on
Where?
this one and you shouldn't wait a second.
Okay. Okay. Okay.
Yeah, it's okay.
Yeah. Now it's okay. So I think let's start. Everything is okay. Okay. Yeah.
Question answer how it was.
So very famous teacher from Prayas India, Satish Kumar is commenting. So you can hear how he get gate exam without studying. So Mr. Satish, there is no such hacks to crack gate exam without studying. Is this a kind of joke or something? You also know that. Okay, let's start machine learning. So guys, machine learning. What is machine learning? As we can see here in the PDF, it says that it is a part of AI which combines data with statistical data to predict an output which can be used to make actionable insight. So machine learning, we can say it's a broader thing, but more broader, not more broader than AI. Okay, so it is covered under the part of AI. Basically, AI covers it, and it combines the data with the statistical data. Why is it we are saying statistical data? Because we have to predict the future references. They have to predict the future outcome from the given input. So how do we do that? We have to predict an output which is kind of certain or maybe uncertain. So the thing is, we don't need such explicit programming. We need the programming to be as low as possible, because in our traditional programming we had a lengthy number of codes. But we did sorry, but we don't need that. Okay, so what we need is, we need, first thing, programming is to be very much less. Second, we have to get the output from our given sets of input. So first, we don't need much programming. Second, we need uh, most accurate kind of output from the given input. And we also need one thing. We need that the output predicted must be must be accurate. Accurate, I mean, not, it will never be 100% accurate, but it should be such that the output is far more better than our brain output, that what we can predict and what versus what the machine can predict. So we want that machine, the thing that machine predicts is most accurate than our prediction. So there are three things we need for machine learning. First, as we all know, that's the part of AI. We all know that, because what we know that the subset of AI, right? What is the subset of AI? It's machine learning, and there is something called deep based learning algorithm also, which combines of neural networks. So we will cover that also. So basically, it's a part of AI, and it combines the original data. Why we need data? Because without data we cannot predict the output. So we need large number of data, either it be the present data or the historical data. Many models are basically the things which are used to predict the output. So they are basically the most integral part of machine learning. So we need large number of data, either it be present data or historical data. So we need that to predict our output. Without data, nothing can be uh, gained, because our models are based on algorithms, and algorithms uses data to find the patterns, draws inferences from all the patterns, and also keep on just regenerating more references from our given data and predict some new kind of output by drawing a new kind of pattern. So the thing is, first, our models which are based on algorithm can draws inferences from the data. First thing. Second, it can find the patterns in our data. Third, it can use the you know it can use the uh, deep learning approach or generative learning approach or iterative based learning. So I think our data is the crucial part for the machine learning, so as written here, we need to predict the output. So how will we do that? For that, the things we already discussed is, first thing, we need data, and then we need a number of data, and then we need to predict the output using a different sets of algorithm, now different models. So now we will know about the historical part, something little bit, historical part we have covered here. We will cover them also. Yeah, historical. So basically, the game of machine began in around 1950s to 1960s. It was the beginning of AI and ML. How it started from the uh, genius named written Alan Turing. He firstly introduced the concept of AI and ML with the Turing test. He did, and exactly in 1959, the main game began by the Arthur Samuel, you know, the mastermind behind the machine learning. We say him. So he coined a term, the can machine think like with human think? He was just asking himself that can machine thinks like we human things? And that is the basic, that how can machine thinks? How can machine do all the works like we humans do? So that was the game that from assemble the idea of machine learning began in a most advanced way. Like he first started developing the algorithms, self-learning algorithm for playing checkers, game. And there is a thing called perceptron, which will study in the neural networks. So the early perceptron in the neural network was discovered by Frank Rosenblatt. So he just developed that thing called early perceptron, which we covered under the architecture of neural network. Okay, so that is what was covered in 1950 to 1960. Basically, that is the history, or we can say the beginning of AI and ML. Later, it was just the expansion part of AI and ML around 1970s to 1980s, where the pattern recognition, stat, sorry, statistical learning, and also the training part for the neural networks. It was refined to the next level because the back propagation algorithm is a very crucial part for neural networks. So why it was refined? Because if we don't refine them, then how can we predict more accurate results? We have not short terms of data. We have large amount of data. So how can we predict that? So there was a kind of thing needed called expansion in our AI and ML, and which happened even after the 1917 and 80s. Today it's also expanding. We are sitting in 2025. So today it's also expanding. It's expanding more and more. We have chat GPTs, we have uh, Gemini. Today we have the advancement like video generation from the text. The simple model was developed like uh, speech to text, speech to text recognition. That is a part of unsupervised learning. We will cover that. So we will get to know about that. So that's all machine learning. That's all AI. Okay. So how the Google VEO generates the video from the text only. So that's all machine learning. And how our Facebook feed or even today Insta feed uh, getting modernized. Some people say that technical term modernized, like how it goes. If you start watching a similar kind of video, if you start liking it, if you start scrolling through the same page, same feed, the Insta or Facebook will suggest you the same kind of videos. How it's going on, how it's being done. It's just because of the machine learning, just because of the AI. You know how you go to the retail store and the same retail store suggest you the same product. How? It's just because of your historical purchase history. We say it's historical data. They have the collected historical data in their data sets, so they just see that this customer has purchased certain products, so they will suggest you the same product. Even in our we say financial journey, machine learning is helping the traders to predict when to trade, when not to trade. So machine learning or AI is helping the traders. And there are lots of application. We are in civil engineering branch, so we as civil engineers, we know that what machine learning can do for our civil engineering branch. It's basically that one line I can say, the lab testing part. Due to the advancement of machine learning, the lab testing part, the result from the lab testing part has been reduced. How? Because in certain kinds of uh, laboratory tests like geotechnical engineering, structural analysis, and all other fluid mechanics also. So there, what we had to do the extensive number of laboratory kind of things, and then we get some results. But due to the advancement of machine learning, we directly fed them the input and they directly predict the result. How is going on? How they are doing it? Just because of their programmed algorithm. Program, why we are saying? Because not explicitly programmed, but some kind of thing. They are trained. They are trained to do such certain kind of works. So they are doing it. So that is what machine learning basically is. Here I have mentioned, here you can see difference between machine learning and traditional programming. Yeah, we all know that traditional programming and number of codes, lengthy codes. Machine learning, very minimal or no codes, right? Basically, here we just fed in the input, traditional programming, and we get the output. But in machine learning part, we give them the input and also we suggest them the output. Then we see that how the things are being generated. It's because of self-made rules that we just discussed, the pattern recognition part. Machine learning is drawing inferences from our given data. So that is what this thing called self-made rules by the machine learning. So we are feeding here input and output both things. Why and what is that? So there are two things. Let's go back. We just discussed that in 1959, Arthur Samuel coined the term that can machine things, and that led to the generation of machine learning. Okay. So after the advancement of basically machine learning, the things which are the most important term used in machine learning is a target which we called as label. Okay, and a variable which is used in statistical term we already discussed. So there is a certain kind of variables which are being used for the statistical part. Okay, so variable used in the statistical part is what is known as feature, and transformation in the variable is known as feature selection. Okay, why we are doing this, we will cover this part more in clustering. Okay, So what is basically feature and what is feature selection and what is level? So level we already discussed. There is a thing called target which machine has to, has to pick up, has to learn from that, has to uh, even ask the user to modify it. So that is what is called as target. Machine learning has to basically learn from it. That is what is called a target. So a technical name for the target is the level. And in our statistical part, there are two things: a statistic and data visualization. So in our statistical part, we have the variable which is being used. That is known as feature, and the transformation in the variable is known as feature selection. So that is what all the things are. Let's cover more about that. Here it's written how machine learning works. So we will cover it. And why do we need machine learning? So it's basic. We all know that human cannot explain their expertise, right? Machine can explain that how it's doing the certain kind of thing, but humans are clever, you know. And we have, if we have created the models, then we need to customize them. And models are basically based on huge amounts of data, as we already discussed. There is no certain small amount of data. We have a large sets of data. So models need to be customized regularly. Why customization is needed? Just for the accuracy part. We need the model to be more accurate, so that it can predict the bestest of the best result. So that is why we need our model to customize, right? And also, machine learning can take their own decisions. Why? Because they have the certain kind of algorithms fitted in them which help to make their self-made rules and help them to just fit in the things, right? Just catch the points, pick up the point that how the things are working, how the things are going. So machine learnings can take their own decisions by the self-made rules with, we can say, minimal human interventions, because we humans have created them. So if we don't intervene in them, then how they are going to predict the certain kind of thing that we need? Okay. So also for the enterprise part, as written here, that it gives a satisfaction to the customer first thing. Why? Because it kind of generates a dopamine in the minds of customer that, wow, this is storage suggesting me this kind of product that I used to buy. My buying purchasing history is this, and my behavioral attraction for the product is this, right? So if the retail store is suggesting me this kind of thing, then won't the customer be happy? It will be. So I think the machine learning has given a kind of change in the perspective, change in the business proposals and business patterns, also helped in the development of new product. So machine learning has done lots of things. So these were the basic, that why do we need machine learning, we covered. There are lots of applications and there are lots of limitations also. Applications which include from the financial services, from our Facebook or Instagram feeds, from our government services, from our what we can say, self-driving cars, from our virtual assistants. So there are range of things, right? The range of things that there is a need of machine learning. We say in government services, we say in uh, financial services, either in banks and all. We say in self-driving cars, in our applications and everywhere. So also CRM is another important thing, customer resource management. Okay, so there is also a need of machine learning, that HR wants to pick up the best employee or the best candidate, right? So how he will do that? He's not going to analyze himself the whole amount of data for a certain employee or the candidate. So he'll feed that thing to a model, which is best on machine learning. So it will give him the best result, that who is the best one, and he will pick up that. So there are a range of things where machine learning is being used today. Okay, and we have also types of machine learning. Here it's written supervised, unsupervised, and reinforcement learning. There is also a thing called semi-supervised learning. Supervised, it includes like regression, okay, regression, and then it includes decision trees, it includes random forest, and then also classification problems. So in the regression part, we have linear regression and multiple regression. In the classification, we have KNN, K nearest neighbor, right? Trees, near bias, SVM, support vector machine, okay, and we also have logistic regression. So that is what covered in supervised learning algorithm. Okay. In the part of unsupervised learning algorithms, we have clustering, which includes uh, PCA, SBD. It's also written here. K means, and in association analysis part, we have a priori, FP growth. Okay, and there is also a thing called hidden Markov mode. So these are all the parts we will cover, right? In the unsupervised, supervised learning, and we have reinforcement learning, which includes AI games, robot navigation, skill acquisition, right? So these are all the things. Why you're doing that, idiot?
लाड़ क्यों देख रहा हूँ आज तुम्हारा लाइव में लाड़ ये भी देख रहा है वो आज देख रहा है इन लोगों को आपस में देख रहा है
पूरा खराब कर दिया भाई.